Alright, so we're going to end Chapter 3 by taking a look at a third line form. At this point, just to kind of summarize what we know, a graph is basically a picture, a visualization of the solution points to an equation. And we have actually learned how to graph two types of equations. For lines, the first form is a general form, ax plus by equals c. And there's an example of that. My a is 3, my b is negative 2, and my c is 12. And so we learned to graph that by either point plotting with intercepts or converting it to slope-intercept form. Right? So slope-intercept form is your y equals mx plus b. And here's an example of that type of line. Our slope is 3/2, so that gives me some direction. And our intercept is going to be at 0, negative 6, which gives me a location to start. So these two forms have been pretty good to us, but it turns out there's a third form that's pretty famous, although it's kind of hard to use. Here's basically the setup of it. So what's happening is we know that the slope of a line is constant. So it doesn't really matter. So let's just say we had a graph here, and so here's my y-axis and here's my x, and I've got some line, right, that's being graphed there. And so it doesn't really matter which 2 points I use, right? They could be these 2 points, they could be those 2 points, or any one of those mix and matches. The slope, right, m, will be constant no matter how I do that. And so we're going to take advantage of that to build this third line form. We know that the slope, right, the slope formula is y2 minus y1 over x2 minus x1. And so what we're going to do, and again, this is constant no matter how I calculate it. So what we're going to basically do is we're going to let x1 and y1 be any point, right, on the line. Anything you can dream up. Alright, and that's what makes this form really strong. As opposed to the slope-intercept form where I needed the y-intercept, this form I can use any point, and we know there's gazillions of them, right? There's an infinite number of points to choose from, which actually makes this pretty strong, right? And so we're going to let x1, y1 be any point, and then we're going to let x comma y be any other point on the line. So this point will vary, right? This point is fixed. Alright, so back over to my picture, let's just say this is my x1 and my y1. So that point is fixed. That's our fixed location. And then we could use this point, this point, this point, or any other point, right, will be our x comma y. So the whole idea behind all our solution points. And so if we basically take these 2 points and plug them into our formula, we get that m equals y minus y1 all over x minus x1. So very subtle difference, right? And here, when we use the formula, I had 2 fixed points, but here I have 1 fixed point, and then xy is any other one I can come up with. So believe it or not, what we have there is an equation of a line, because I could use any solution point in that formula to do that. But that's really not easy to look at. So what we're going to do is we're going to clear the fraction by multiplying both sides by x minus x1. And as we've seen over here, that'll cancel out, right? And we're going to be left with y minus y1. Let me use the commutative property there to rewrite that. And then one more thing, equality goes either way. So we get y minus y1 equals m minus x1. And there is our third form. It is called the point slope form. So named because it requires a point, right? x1 comma y1 is a fixed point, and the slope, right, is the same slope that we've been having. And so basically there's another equation of a line. So for example, for this one, we could say something like y minus 3 equals 3/2 x minus 6. And so there would be an example of the point slope form. And what I'm telling you right there is the slope, right? So that's where the slope's located at, my m, right? Let me write the formula right on top of it so we can kind of All right, so there's my m, so my direction of movement's there. And then x1 is whatever is being subtracted from x. So what number is being subtracted? Listen real carefully. X minus 6. So what we're subtracting is 6. So x1 is 6. And then again, careful about subtraction, right? What are we subtracting? Y minus 3. So y1 would be 3. So the fixed point that we have is 6, 3. All right, and so there's your introduction to our new form. Obviously, we have much more to do with it. Next video, what I'll do is expand on this a little bit more, connect these three, and then what we'll also do is start to graph and find equations. But there's your new form, and we got a lot of work to do. See you guys in the next video.